All right, next few examples are just going to look at using our 5 kinematics equations again. So example 1.2.1 says a motorcyclist is traveling 15 meters per second forward and applies the brakes. The motorcycle slows down at 5 meters per second squared backward. Determine the motorcycle's braking distance if he comes to a complete stop. Okay, so remember from last year, if you were in my class, what I really like you to get in the habit of doing is stating those variables, especially when we get into some longer, more complicated equations. So especially you know which one you're looking at to use to find the right answer. Okay, so we're going to look at defining each of our variables here. So to start, 15 meters per second forward is the initial velocity of the object in this case. Reason we know that is just look at the situation of the problem. We're traveling, we're braking, and then we want to come to a complete stop. So the 15 meters per second forward is the initial velocity of that object. Second piece of information we're given is the acceleration of the object. The acceleration of the object is 5.0 meters per second squared backward. So I'm just going to use F as forward and B as backward. Okay. And then even though there's not any more information technically given to us in the problem or any more values, the last sentence says determine the motorcycle's braking distance if he comes to a complete stop. So that complete stop there tells us that last piece of information we need, which is the final velocity of that object. And the final velocity would then be 0 meters per second, either forward or backward. Okay. What you might want to get into the habit of doing, so we are looking for either the displacement or the final distance that he travels in this case. I know the question does say distance, but I'm going to cross that out here and let's say we're looking for the braking displacement because I do want us to talk about the direction of the object as well. Okay. So what you can get into the habit of doing in this class, if you want to not be able to carry those directions all the way through, is, well, let's just define a direction as positive or negative. So what I'm going to do for this problem, before I start, is at the top of this problem, I'm going to say that anything in the forward direction for me is going to be a positive value. That means anything that's going backwards is going to be negative when we talk about one-dimensional motion. Okay. Now we need to look at the 4 variables that we've been given: initial velocity, acceleration, final velocity, and displacement, and think about which of our 5 kinematics equations we're going to use. Okay, the one that is going to allow us, or that has these 4 variables involved, says that v final squared is equal to v initial squared plus 2 times the acceleration of the object times the displacement of the object. Okay. We're looking for displacement, so we want to rearrange this equation in order to solve for that displacement. So to start, I'm going to subtract v initial squared from this side of the equation, which would cancel that, which means we now have v final squared minus v initial squared is equal to 2 times acceleration times displacement. Okay. Because these 3 values are all multiplied by each other, 2 times acceleration times displacement, I can simply divide out the factors that we don't want, which are 2 times acceleration, which is going to cancel it, leaving us only with displacement. Okay, so we would have v final squared minus v initial squared over 2 times acceleration is equal to the displacement. Okay. Now that you've rearranged and we know what all of our values are based on indicating them here on the left-hand side, this problem just becomes a plug and chug in your calculator. Okay, so the displacement is equal to v final squared minus v initial squared divided by 2 times acceleration. The nice thing is we know v final squared is 0. So really, the displacement of this object is really just negative the initial velocity of the object squared divided by 2 times that acceleration. So the initial velocity was the initial velocity was 15 meters per second, and it was forward, and that's why I have this positive value in front. Okay, and then divided by 2 times our acceleration, and our acceleration was 5 meters per second squared backwards. So what that means is when I go to plug it in now, because I said anything forwards was going to be positive, I'm making this acceleration negative 5 meters per second squared. Okay, 15 squared is 225. So now you get negative 225 meters squared per second squared on top, divided by 2 times negative 5 is negative 10 meters per second squared. Okay. Negative 225 divided by negative 10 leaves you with 22.5. And then if we look at the units here, you get meters per sec or meters squared divided by meters. So that's going to cancel out one factor there, and then you have seconds squared divided by seconds. So all of those cancel, leaving you only with meters. Okay. Now what you want to look at is obviously we need to go to significant figures. Okay. So if we look at 15, 15 had 3 significant figures. 5 had 2. So we're going to round our final answer here to 2 significant figures. Okay, and then the other thing that we need to look at is the fact that we had a negative divided by a negative means our final answer here comes out to a positive value. So that's going to tell us the direction of our displacement. So the displacement of the object over that braking distance, is, if we round to significant figures, we need to look at the value right after the 22. So 0.5 means we're rounding up. So I get 23 meters, and because it's positive, we know the direction of that displacement is forward.